Okay, firstly, good afternoon, Professor and college. I'm Pamrit Kapkers, and today I'm going to present my thesis, the bioenergy supply chain simulation and improvement based on Thailand alternative energy development plans. And my advisor is Professor Elena Griasina. And in this presentation, I will cover 5 topics. And let us start with my first topic, the background and problem statement. Firstly, let's talk about Thailand. Thailand is a tropical country located in Southeast Asia, and basically we are the agriculture-based countries, which we have the crops, major crops. But we hasn't focused on just about agriculture development. We also focus on the energy development as well, especially in alternative energy. And since 2015, Thailand has developed our own energy plan, which is called Thailand Integrated Energy Blueprint. And in this blueprint is described about the 5 fields of energy. But I want us to focus on the AEDP, the Alternative Energy Development Plan. This plan, AEDP, is describe the target that how much energy consumption and how much energy alternative energy ratios we want to accomplish in year 2015, 2021, and 2036. But I want us to focus on this. If you see here, last year 2020, this is our real accomplishment. But if you compare to this target in this year, 2021, you can see that we still miss some goal. In biomass, we still miss for 11%, biogas for 34%, solid waste for 33%, and bioethanol for 15%. So the question is why we still miss the goal, why Thailand still miss the goal. Maybe it's because of we lack of the amount of feedstock, biomass, biogas, or maybe because of we lack of the power plant, the maximum capacity of power plant is still less than the target we aim. Or maybe because it's not those 2 problems, but it's because of the unwell supply chain management, or maybe because of the bottlenecks occur in the supply chain. So with this problem, I would like to study on the bioenergy supply chain of Thailand and investigate the problem. So my thesis goals are, the first one is to make a mathematical model and simulate the Thailand bioenergy supply chain, which I will focus on biomass, biogas from energy crops, and ethanol. The second one is to investigate the problems that make the real bioenergy consumption ratios lower than the target we aim in year 2021. And my third goal is to make suggestions to improve Thailand bioenergy supply chain according to the plan in 2021. Okay, but before we start making a model, start making a simulation, firstly we have to know about the supply chain profile. Okay, let's start with the supply chain. In Thailand, bioenergy supply chains, we have 5 major players. The first one is crop suppliers or agriculturers. Second one is plant or factories. Third one is distributor, and the fourth one is consumer, and the last one, the fifth one is transporter. And let me explain a little bit about how the process flows. For feedstock such as biomass, it can be used as a fuel to produce electricity directly, or it may be passed to some process to produce biogas first, and then use this biogas to produce electricity. And so far, from I have known in Thailand, we have 3 different technologies for biomass power plant, which are cogeneration, direct firing, and gasification. And for biogas power plant, we have either steam turbine or gas turbine. And which this different technology mean different energy coefficients, which we have to consider about the energy conversion. But I will talk about it later. And for crops, for feedstock such as crops, is usually the crops will pass to the crops bread products manufacturing to produce some product first, and then through this product we will get biomass and waste as it byproducts, and we will use this biomass and waste to produce electricity and ethanol afterward. The electricity will deliver to our distributor, which is PEA and MEA. These two are government companies. And for ethanol, it will deliver to the authorized companies in Thailand, which is PTT. And then it will deliver to consumer afterwards. Okay, and then now see the supply chain profiles. Thailand has 77 provinces which supply different type and different amount of crops. We have 12 PEA stations. We have 220 biomass power plants, 187 biogas power plants, and 28 bioethanol plants. And here is some crops profile. The available biomass in Thailand mostly derived from our major crops, which is rice, sugarcane, corn, cassava, palm, rubber tea, and coconut. And you can see some summer profile in different months here in graph. And after we know the supply chain, we know the workflow in supply chain and some profiles. So now we can start making the mathematical models. And here my mathematical models, I will use Python to programming. And my model is linear programming. My variables is the amount of biomass that's delivered from supplier to plant at each time. And my time step is 1 day. So totally in 1 year, we will have 265 days. And okay, my objective function is to minimize the total annual cost, which consists of the material cost, transportation cost, production cost, and distribution cost. And the constraint that I have to consider is the first one is the limitation of crops availability. Second one is the limitation of plants maximum production. Third one is the limitation of plant feedstock inventory. And fourth one is limitation of distributor maximum capacity. And the last one is the balance between supply and demand. And also, we also have to know about how to convert crops to biomass, also crops to biogas and waste, and also about how to convert feedstock to heat, how to convert feedstock to ethanol, how to convert heat to electricity, and about how to convert between power and energy. And my last topic is my conclusion. So in conclusion, my problem is about the actual Thailand's bioenergy consumption and accomplishment still less than the target we planned in 2021. And my goal is to make a mathematical model and simulate the Thailand's bioenergy supply chain, and also investigate the problem that make our real production, real consumption less than the target we planned. My methodology is using Python to do linear programming to find the amount of biomass that deliver from supplier to plants at each time step. And this is all my presentation, and thank you for your attention.
Thank you, Paul.
Thank you.
Thank you.
Thank
you. Who would like to start with questions?
Yeah, Henny, you can
just
start.
a couple of questions quickly. So first thing is, would you consider your master thesis to be part of some, let's say, white paper for your government? Could you sort of promote this work that you're doing to the authorities in your country, and assuming that you get, interesting results and so on and so forth, but turn this into something useful for the authorities and not being just something that gets you a grade and that's it?
Yes, thank you for this question. I actually want to present this to Thai government. I write an email quite a long time ago to Ministry of Energy, but they haven't replied to me yet. But I want to present it to Thailand as well.
Okay, because the point is maybe you could attend at some point, I don't know when, some conference related to this topic and meet with, let's say, high-level people there, and or why not advertise this on, let's say, Twitter or LinkedIn, etc. Because if you manage to get something, let's say, useful, then it is very, very good, because this is an important problem in your country. And if you could contribute at least part of the solution, that would be very nice for everybody. Now, just a quick question again. If you go back to your slide with equations.
Equation?
Yes, you showed some equations, yes. So all these, basically, did you write them on your own, or did you adapt them from?
First, I write on my own by understanding the supply chain. So I have to know what is input, what is output, and then adapting this supply chain, which I also make on my own for my understanding. To write this equation, I write my own.
Mm-hmm. Okay, so because for me the idea is that you really show that this is exactly your work and your ideas and so on and so forth. I didn't get that you did that on your own, and okay. So thank you. That's all for me.
Thank you.
Peter, would you like to ask anything?
Yeah, just a quick question. So it looks like you're doing some optimization.
Yes.
And this is like linear optimization, and this is a pretty standard model in this supply chain research. Yeah? Well, there is this field of study which is called supply chain. Like this linear programming is like the first thing to do. So, but what are the methods that your government uses at present? Like typically, this kind of algorithms are implemented inside of those, well, ministries or whatever plans at the planning stage.
Okay, you mean what Thailand government do to
Yeah.
plan this goal, right?
Yes, yes.
This
So how is it realized now?
In the report, in the journal report of this plan, they haven't stated about their methodology. It's like they collect the historical trend, and then they said what they go in the future. So I also don't know how they derive what is their method. So this is one of my point to develop my mathematical models in this thesis.
But do you have data to actually compare your results with what happens now? So for example, you have available data on the production of power, I guess. And then if you, for example, have the available data on the primary energy sources that you are using, then you can clearly show that the method that you develop, like a software that you develop, can allow to produce more, for example, out of the same set of primary energy resources. So you need to compare it with something that would be really good, because otherwise you say, okay, I wrote a method, but maybe they're already using something like that.
Okay,
see what I mean?
You mean that I have to model something and compare? For example, if I use data in 2020, and my result should be compared to the real result in 2020, right?
Yes. So with the results that they already have, if you have the input data, so you definitely have the data on energy production, but you probably don't have the data on the amount of primary resources that were consumed.
I have I mean resource, right?
Well, yeah, if you go to your formulation, so if you know the inputs to your system, the true inputs.
Oh, okay. I will switch. I have some backup. Okay. Now what I know. Do you see my present, but in not a full screen, right?
Yeah, that's okay.
Okay. Now I have the In the slide I show the crops in a year, right? In annual. But now I know some data to convert, how to convert this crops to biomass, which is I got from the Ministry of Energy in Thailand, and also yes, the heat capacity, moisture, and other data. I hope this.
Yes, I understand that. This is the data how you convert things to electricity. But what I'm saying is that there is real live data on how much energy was produced. Let's say a year ago.
I got the list of power plant, of biomass power plant from also Ministry of Energy, but I haven't shown in this. I maybe.
Okay. Yeah, let's not spend too much time yet. I'm okay.
But I got data from Ministry in Thailand.
Okay.
Yes, I got 270 factory data.
Okay, thanks, Paul, for your presentation.